Now we will move towards the fourth part of the theorem. That is nothing but we have to prove minus 1 multiplied by x is equal to minus x. Now the question is how to prove it. Now we already know that x plus minus x is equal to 0 vector. So this fact can be used to prove minus 1 multiplied by x is equal to minus x. Now the question is how to prove it. Let me show you. Just I have written here to prove minus 1 x is equal to minus x, but we already have x plus minus x is equal to 0 vector. Now take a note that before to this we have already proved that the additive inverse is unique. So if I am able to prove, now we show x plus minus 1 multiplied by x is equal to a 0 vector. Now you will wonder how this 2 will imply minus 1 multiplied by x is equal to minus x. As I told you before, we have proved additive inverse is unique. So proving this will imply that this minus 1 multiplied by x is the additive inverse of x, but we already know that this minus x is the additive inverse of x, but there can be only one inverse, we cannot have two inverse. So thus this is possible only if this minus x is equal to minus 1 multiplied by x. So this is how we are going to proceed. So our job is to only prove this x plus minus 1 multiplied by x is equal to a 0 vector. This can be easily proved. I will consider LHS. So consider LHS x plus minus 1 multiplied by x which is equal to, but according to P8, how can you write this x? This x can be written as 1 dot x plus minus 1 multiplied by x which is equal to. Now just think properly which property can be used here. Because this is a scalar, you can treat it as alpha, this is our vector, this is a scalar, you can treat it as some beta. So this is of the type alpha u plus beta u. So which is the property that involves alpha u plus beta u? If you go back, and that is nothing but this one, this, okay, P6. So alpha u plus beta u is nothing but alpha plus beta u, that u can be taken common. Same thing we will do here. So this will be equal to 1 plus minus 1 and that x is out. This is by P6. But what is 1 plus minus 1? That is our scalar 0, 0 multiplied by x. But the first part of the theorem says that the scalar 0 multiplied by x is nothing but our vector 0. So what we have proved? Therefore, this x plus minus 1 multiplied by x is 0 vector. But additive inverse is unique. Thus, okay, you can say that minus 1 multiplied by x should be equal to minus x. And that is exactly we wanted to prove. Now this fifth one, I leave it to you because it is exactly same as the first part of the proof. Only the thing is, over here we are having a 0 vector and over there we were having, what we were having? A 0 scalar. So if you remember the proof, the idea that we used was, we have written this scalar 0 as 0 plus 0. So over here we are going to write this 0 vector as 0 plus 0. I think this is only the basic difference, otherwise proof is exactly same. So that is homework. Now we will move towards the sixth part of the theorem, but before that let us try to understand what exactly fifth part is saying. The first part of the theorem was saying that scalar 0 multiplied by any vector is equal to 0 vector. Second was saying identity element in a vector space is always unique. The third one was saying additive inverse of each element in the vector space is unique. The fourth one was saying minus 1 multiplied by x is minus x. Fifth one is saying scalar multiplied by a 0 vector is always a 0 vector. Now we will prove the sixth one. So according to the sixth property, if scalar multiplied by vector is equal to 0 vector, then the either scalar should be equal to 0 or this vector should be equal to 0. Now take a note that whenever I say scalar equal to 0, we are having a scalar 0. Whenever I say vector is equal to 0, I am having a 0 vector. Okay, that is the thing to note. So let us begin. So we will assume that alpha x is equal to 0 and we will prove that alpha is equal to 0 or x is equal to 0 vector. So I will say let alpha x is equal to 0. Now take a note that we have to prove either alpha is equal to 0 or x is equal to 0. But if alpha is equal to 0, then we are through, right? Because we have to prove either alpha is 0 or x is 0. So if alpha is equal to 0, then we are through because we wanted to show either one of them is 0. So I will say if alpha is equal to 0, then we are through because that is exactly what we wanted to prove. Okay. So let us assume, suppose alpha is non-zero. Now since we have assumed alpha is non-zero, we will prove that x is equal to 0 vector. Now since alpha is non-zero, what I will do is I will multiply, let us call it as star, I will multiply this star by alpha inverse. So I will say pre-multiply star by alpha inverse. Therefore what we will get? Therefore alpha inverse multiplied by alpha x will be alpha inverse multiplied by this 0 vector. But right now in the fifth property, which you are going to prove, what we have discussed, that scalar multiplied by a 0 vector is a 0 vector. So we will have 0 vector here. And what about on the left hand side? This thing can be written as alpha inverse alpha x. Can you tell the property? That's right, P7. But what is alpha inverse alpha? Okay, that is nothing but 1. So therefore 1 dot x will be equal to this 0 vector, but according to P8 1 dot x is x. So therefore x is equal to 0 vector, and that is exactly we wanted to prove. So that's all about this theorem. Thank you.